Hello, let's do the New York Times Hard Sudoku for January 7th, 2025. I haven't mentioned this in a bit, and I may have some new people trickling in to watch these videos. So if there's ever anything I do and I don't explain it well enough here, or I'm going too fast for you, there is a link in the description to an hour-plus long video where I go very slowly through a puzzle and talk about the basic stuff that you should be looking for step by step. And I put a lot of effort into that video. So I always have that linked in the description as well as the link to solve this puzzle using the software that I do called Sudoku Pad. It is just a website, but it works on any device because you can just browse to it in a web browser, and it works very well on desktop or mobile. And it's completely free. And it supports certain features I use that the built-in New York Times software doesn't. All right, cool. With all that said, there is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we're going to start over here. We do have two 9s. It's a 9 over here. This 4 doesn't seem to do anything. It's so close to doing something, but no. All right, we've got the 2, 3, and 7. So 2, unfortunately, doesn't do anything. The 3 also, yeah, not quite there with the 3 either. We do have 2 7s and then 2 more 7s. So anytime you have 4 of a digit looking at the box, that digit can be placed into that box. If it isn't already. All right, so 2, 3, 7. We also have an 8. That's the only thing we haven't looked at yet. Unfortunately, 8s aren't really doing much. So I don't think there's much to find in this band. We do have a row that's down to 4 or fewer digits. So let's take a look at that. We need 1, 4, 5, 6. So we know these both can't be 4. So these are 1, 5, 6, and this can't be a 6. This can't be a 1 or a 5, so this is 4, 6. And this can't be a 1 or a 6, so it's 4, 5. Pretty interesting. So it doesn't resolve. We do know that the 1 is claimed here, so that's pretty handy. Oh, I didn't scan the 1. Oops! Had I scanned the 1, I would have it placed here. All right. Well, better late than never. Okay. I just somehow missed it in my scanning order. All right. In fact, this one looks down here, and whenever you have a full box row or box column like this, it's extremely handy because this 1 looks down through here, meaning the 1 is actually in one of these 2 because this one looks in. And that's going to point down along with this one. This one looks in, putting one of these 2. You could also see it the other way around and ask where 1 is in this column. And it ends up being in one of these 2 in the column, which then claims this column, claims these 3 cells, leaving just these in this column. So, I mean, you get the same exact result. So just see it however you'd like to, or just multiple chances to see the same thing. I'm looking at these 3 cells because I'm noticing this is full. These 2 are full. If 1, 4, 7, or 9 isn't yet placed in the column, then that's helpful for the column. So we can see that 1 we already took care of, and the 7 and the 9 are already in the column, but the 4 can't be here, and the 4 can't be here either. And so 4 is limited to these 2, and that does do claiming. Let me just explain claiming real quick, because I think it is the most often missed strategy that might be necessary for a New York Times hard puzzle. So we're talking about this column here. Think about this column. Remember, every column, just like every row in every box, every column needs 1 through 9 ones each, which means that we do need to place a 4 in the column. We can't get away with not placing a 4 in the column. And so then the question you ask is, well, where can I place a 4 in the column? And I can't place it in any of these cells. And so what that means is 4 is going to end up in this cell or this cell. Whichever cell it ends up in, that's going to be the 4 also for box 8. It's kind of like a coincidence, right? Where we're going to need a 4 for this column, and coincidentally, the 4 for this column will also end up in box 8, meaning it's the 4 for box 8. Meaning these can't be 4. These cells can't be 4 because the 4 is here. So it can't also be here. We can't repeat it in the box. And so that might affect these columns as well in terms of where 4 can go. Unfortunately, it doesn't. It also just directly affects these cells, saying, hey, these aren't 4. So that can cause things like make it singles or create pairs or triples where otherwise it wouldn't. So it's quite handy. This corner mark here is going to remind us that these can't be 4. At least ideally it does. And so that's going to potentially come in handy when we start scanning this box more, but we're not there yet. And then I want to look, the other thing to look for is any other digits in these columns that aren't placed in this box already. And if so, those do the same thing as the ones. But unfortunately, the 5 and the 8 are already in the column. So they're already in this box, so we can't do anything with that. So I think at this point, I am going to move on to the next band here. We're just going to repeat what we did. So I'm going to start with this 1. We already have it marked here. Unfortunately, it could be in any of these 3. This box is probably a good one to look at in general, but we'll get there. This 6 and this 6 look into here, putting a 6 in one of these 2. We also have the 3, 8, 5, and 8. I always start with the box with the fewest givens, because they affect the boxes with the more givens. Anyway, these 3s look in, this 3 looks down. That places this 3. We can follow up on that by putting a 3 in one of these 2. All right, so I did the 3. We do have the 2 5s here. That puts a 5 in one of these 2. Now, what I'm immediately looking for when I'm corner mark this is whether this box or this box has a similar restriction on 5s to these 2 columns. And that would tell us about where 5 goes in this column. Unfortunately, 5 can escape here in this box. And it can be in either of these in this box. So we can't actually do anything with that, but we always want to be looking for that. Same with like these 3s, these 4s, these 1s. We want to be looking for that kind of thing. Especially if it's not placed at all. If it's not placed at all in the band or stack, right? 3 is not placed at all in this band. So we would want to look to see if there's another box with 3 limited to these 2 rows. 5 is not placed in this stack. That's why we would look. 4, we don't care because there's already a 4. All right, hopefully that's clear. If I see an actual case of it, I will definitely show you and use it. All right, so that was the 5. We also have the 8. Okay, so this is actually handy. This 8 looks in, this 8 looks in. I call this a crossing, and you can look for this directly because we got this 3, 6 here. And so anything that looks through the 3, 6, right? You can see how it's kind of like the 3, 6, you can think of it as like bumper bowling. I don't know. That's a weird example. But this 8 smashes through here. And what it does is it eliminates 8 from 3 cells. And those 3 cells avoid the 6 and 3. We know 6 and 3 also aren't 8. So that's already 5 cells that can't be 8. And so any 8 over here is going to remove it from 2 more, as long as it's not in this row. And then that leaves just 2 places for 8 in this box. Now that does something also interesting, which is we have corner marked the 5s and the 8s into the same 2 cells in this box. So if you think about what that means, it means one of these 2 cells has to be 5 and one of these 2 cells has to be 8. Well, these 2 cells only have 2 values. If one of them has to be 5 and one of them has to be 8, that's what we call a hidden 5-8 pair. And what it does is it says, well, we can't put any other digits into those 2 cells. That's what hiddens do. So because this is a hidden 5-8 pair, you can think about what digits can these not be anymore. So for example, they can't be a 2 anymore. This one can't be 2 anymore. If you look at the row and you look at the column and you look at the box, there's no 2 actually already in the row, column, or box. So you'd think that 2 would be an option. But the hidden 5-8 pair has told us 2 is actually not an option. And that's very powerful. So this 2 looking in, these can't be 2, this can't be 2. So 2 is limited to these 3. You could easily see how it would be limited to even fewer, and that would be super useful, especially if it's limited down to 1. But it's not just the 2. We already knew they couldn't be 3 or 4. They can be a 5. We knew they couldn't be 6. But now you can see they also can't be 7 now. And again, there's no reason in the rows, columns, or boxes that they shouldn't be able to be 7. But we can see that this 7 looking down here, and now this hidden 5-8 pair removing 7, does put a 7 in one of these 2 cells, which is something we wouldn't have been able to figure out without the hidden 5-8 pair, at least not easily. And so the 7 in one of these 2 cells does point into this box. Now, pointing is the kind of other side of the coin to claiming, where here in this box, we have limited 7 to 2 cells, and those 2 cells happen to both be in row 5. So therefore, this will also be the 7 for row 5. So we cannot put a 7 over here, also in row 5, in this box. And this 7 says not here. So the 7 ends up in one of these 2 cells. You can also see that for the row. The hidden 5-8 pair also told us 7 was here or here in the row. See it however you'd like to, whatever comfortable for your scanning. Now, 8 can be one of these 2. 9 is the last digit that was removed from these 2. So we want to see the effect on this box. There are no 9s around to really affect the box much. But we can see that this row, this is kind of the final follow-up. I like to look at the less obvious things the hidden pair does before I move on and just start, looking at the more straightforward stuff. So the most straightforward thing is this is a 5-8 pair in the row, meaning there's only 3 digits left to place in the row because we know the 5-8 are basically over here. The pair eliminates it from the rest of the row. So what else do we need? And we can see that we need a 2, 7, and 9. So we can just fill out 2, 7, 9 here, and this one's not a 7, which we already told us that 7's in one of these two. We already knew that. All right, that's handy. There's also 4 digits left here, 4 digits left here. Did I go through? I think I went through every. No, I didn't actually look at these digits yet. So let's just take a quick look. We took care of the 3s. Does the 4 do anything? Not that I can tell. The 5 we took care of. The 6 we took care of, and the 7 we took care of. Okay, so let's look at this box. The first thing I want to look at, because these 4 are full, we basically got an empty row here, empty row here. With a filled digit, that's even better. But what we want to look for is anything here or anything here that's not already placed in the box. Unfortunately, 3, 5, 6, and 4 are already these 4 digits, so that doesn't actually help us. But we can look at the rest of this box and what digits are left. We need the 1, 2, 8, 9. So this cannot be the 8 or the 9, so it's only 1, 2. I do believe this can be any of 8, 1, 2, 8, 9. This can't be an 8, so it's 1, 2, 9. All right. But actually, that means 8 can only go here. So I missed that about 8s somehow. Oh, the 5-8 pair, right. So what I missed is the buddy for the 5-8 pair looking into here. And then this 8 looks up. So that places the 8 in the box. That's handy. Now, placing that 8 did reduce this column to 4 open cells. It also gave a buddy for this 8. So let's do that first. But let's look at this column. So what do we need? We need 1, 2, 5, and 9. This can't be a 9. So we know the 9 is down here somewhere. Does that help me at all? Not particularly. We know the 9's here. Okay. 1, 2, 5, 9. Well, this can't be 1 or 5, so this is only 2, 9. I generally only center mark cells with 3 or fewer options. This can be any of 1, 2, 5, 9. This can't be a 9, so it's 1, 2, 5. Oh, it can't be 1 either. Okay. Everything looking good. I don't think there's an obvious follow-up I haven't done. Okay. This row is down to 4 digits, and this box is down to 4 digits, so we got more penciling potentially to do. I always take a look at a row column box that's down to 4 or fewer. I may or may not pencil every cell, depending. We need 1, 2, 4, and 9 here as well. It's the same thing. 1, 2, 4, 9. So this can't be 1. So this is 2, 4, 9. This can be any of them. And this can't be 1. So this is 2, 4, 9. Now, when I said that 2 of them couldn't be 1, that triggered in my head, well, which ones can be 1? Unfortunately, both of these can be 1. So that doesn't help us. And so that means this box is 2, 4, 7, 9. We know this one's not 7, so this is 2, 4, 9. This isn't 2, so it's 4, 7, 9. All right. So we marked up a bunch of stuff that isn't immediately helpful, but it might be later. All right, we're moving on to the last band here, the final band. This 5 looks in, this 5 looks in. Notice that is a crossing on the 4, 7. Puts a 5 in one of these 2 cells. That 5 points in along with this 5, putting a 5 somewhere over here. I'm very interested in limiting 5 to 2 columns here, but we have not done so. Okay, so that was the 5. We have the 1. We already have it marked here. I don't see a good way to restrict it over here. Okay, we have the 2 8s along with these 2 8s. Okay, 4 8s looking into the box. You can always place that right at the start, but I don't think it would have helped us very much. 1, 2. Okay, I was just looking at what digits were here, looking down. But, so I did the 1, 8, the 5, 8. We need the 4 and the 7. Unlikely that they're helpful, but we'll see. Yeah, I'm not seeing anything with 4 or 7. Okay. Cool. So we have finished our band scanning. Now what we can do is we can look at our stacks, and really all we're looking for is any buddies I might have missed in the stacks. So we just have to go through the 2 smaller boxes and look for buddies directly in the stack. So the 4s are done, the 7s are done, the 9 does not have a buddy, and then we also have this 8, and we already marked it. Over here, you can do this very quickly. Over here, we do have 2 5s, so I missed these 5s. When I corner mark them, I am checking these 2 boxes. Unfortunately, we don't match up. in terms of rows for 5s. We also have the 8, which are done. And then we've got the 3 that we haven't looked at, but it doesn't have a buddy. Okay. Yeah, just double checking that. All right, and here we have the 1 and the 8. The 1s are done. The 8 does not have a buddy. And then we've got the 3 and the 6. We got the 3s taken care of. 6. The 6 actually does look into here, putting 6 in one of these two, which could be handy. If we get another digit down here that's not already placed in this box, then that'll join the 6, creating a hidden pair, and that would be quite nice. It doesn't, I mean, it will happen, but it may not be useful by the time it happens, but it might be. All right, so we basically finished our first pass on scanning. The next thing to look for is if there's any low-hanging fruit that I might have missed. Low-hanging fruit is what I call any row, column, or box with 4 or fewer digits. There's also a few other low-hanging fruit options, but we're going to start there. I'm seeing this column is down to 4 digits. So we need the 1, 2, 3, and 6. So this isn't a 1. This is 2, 3, 6. Wonderful. This isn't a 1 either. 2, 3, 6. Now, if this couldn't be 1, we'd be very happy, but unfortunately it can be. Okay, so I don't see anything that does immediately. Okay. Any other low-hanging fruit? Rows, columns, boxes, 4 or fewer. We already took care of those. I'm not seeing any. Okay, the next thing to look for is we've corner marked a bunch of boxes. So if there's ever any cells, like maybe this one, that is avoiding a bunch of corner marks, that's telling you that it not only is it not all the givens, it's not 1, 2, 3, 7, it's also not any of the corner marks. It's not 6 or 9. It's already 5 digits, it isn't. So we want to take a look at what it can be. So it looks like it can't be 1, 2, 3, it can't be a 4, it could be 5, can't be 6 or 7, it could be 8, but it can't be 9. So you can see it's down to 5, 8 only. That can definitely come in handy. And we're going to look for more like that. I mean, this cell, oh, we know this cell's 1, 2, 4, 9. That's not helpful. Okay. These two cells aren't 5, 9, so we want to take a look. They could be 1, 2, 3, 6. Well, this one can't be a 1, so this is 2, 3, 6. 7, 8, 9 are accounted for. Fortunately, this can be, yeah, we already looked at the column for this, so it's 1, 2, 3, 6. We got a bunch of 2, 3, 6s. Unfortunately, they don't really form a triple at the moment. All right. 1, 5, 2, 5. Got a lot of restrictions, but... Oh, the other thing we want to be looking for is box by box. Just look at the corner marks and make sure they were respected. Make sure the pointing's respected. Make sure the claiming's respected. They don't all point and claim in a useful way, but it doesn't hurt to just pay attention to each one and make sure we didn't overmark anything. The 1s, the 6s, the 7s. I try to do this quickly, but okay. So what other low-hanging fruit do we have? I'm clearly missing something important. 1, 2, 4, 9. Maybe these two cells that aren't 1, 5, 7, 8, 9. So let's just write out what they could be that aren't in the box. So in the what's not accounted for in the box, we need 2, 3, 4, 6. Yeah, and this can't be 3 or 4. So that's down to 2, 6. Yeah, that makes sense. I should have actually marked that one earlier. This unfortunately can be all of 2, 3, 4, 6. I don't see any reason it shouldn't be. But yeah, this 2, 6 is because this column is down to 4 digits, and I did not pay attention to that. So this is down to 1, 2, 4, 6. So this is 2, 4, 6. This is 1, 2, 6 because it's not 4. Unfortunately, it doesn't help. I'm thinking about doing this row just because it's down to 5 and 2 of them are by values. By values just means it's down to 2 digits. So I need 2, 3, 5, 6, 8. So once you get into 5, it's hard to remember all of them. But this can't be 2, 3. So this is only 5, 6, 8. I'm really trying to make this match up with something. We do have something we could use. I'm not going to use this, but I do like to talk about it when I find it. This is the general class of this technique is called a uniqueness technique, and I do not use them in these puzzles. Most puzzles I don't use them. A uniqueness technique assumes that there's only one solution to the puzzle. Now that is going to be true. We know every well-crafted Sudoku, which includes the New York Times ones, especially computer-generated ones where the person who created the generator knows what they're doing. There's going to be only one solution to the puzzle. If there was more than one solution to the puzzle, we wouldn't be able to logically solve it, because there would always be some point where we get to the point where we have to choose a solution, which means guessing a digit. And that's never going to happen in a Sudoku like this, which means that there is only one solution to it. Because we know there's only one solution to it, we know this is a 6. Because imagine this was not a 6. Well, if this wasn't a 6, then how would these 5-8 pairs ever get resolved? In order to resolve these 5-8 pairs, we'd need something in their rows, columns, or boxes that was a 5 or an 8. But these 5-8 pairs are in 2 rows, 2 columns, and 2 boxes, which means this 5-8 pair says we can't have another 5-8 in this column. This 5-8 pair says we can't have another 5-8 pair in this column. There is also 5-8 pairs in these rows, and there's also 5-8 pairs in the boxes from these. And so nothing resolves it, which means there will be at least 2 solutions to this puzzle, one where the 5s are here and one where the 5s are here, and nothing external would care. And so as a result, we know we can't do that because that would make more than one solution, which contradicts our assumed rule that there's only one solution, and that lets us place the 6. Now, you do need to be careful. You can only do this if they are in 2 rows, 2 columns, and 2 boxes. People make the mistake a lot of seeing it here, which is a random example, and they think they can do it here, and that is not the case because the boxes, we're in 4 boxes. That's a very common mistake. It's also a mistake often to do it in variant Sudokus where there's constraints that might be able to affect those digits remotely. Anyway, we are not going to use that, but we do know, I'm going to highlight this. This is going to end up a 6. That's my prediction. It's logically true because I know there's only one solution, but we're not going to use that. Let's find something else. And the reason I don't like to use that is because I like to prove that the solution I encountered is the only solution. And the way to do that is to logically solve without assuming one solution. Once you start assuming one solution, you can't prove that that was the only solution. Anyway, we do have this 5-8 pair, as I pointed out. And so that does make this a 4. So that's probably going to help. That's going to just do it anyway. That does make this a 1-5 pair. 1-5 pair for the box means that can't be 5. So that's our 2. And we're left with 3, 6, 8 here. This can't be 6. And so based on our corner marks, this is where corner marks come in handy. I removed this 6 corner mark, which places this 6 because it's the only 6 corner mark left in the box, telling us that 6 has to be in that cell. When I do that, that removed a 1 corner mark because now it's 6. And that places the 1 in. And that lets you very quickly cascade 2-7 pair here, 4-9 pair here. Okay, we get the 5 and the 1 here. That's not a 5, so that's 5 and 9. That's not a 2. 3-6 pair means we can finish this digit, whatever it is. It looks like it's a 1. Okay, that gives us the 1 and the 4, and the 6 gets finished. 2, 3, and 6 here. Actually, not resolved. Okay, 2-7 pair. That means this is 4-9. 4-9 pair means this is going to be a triple. We need 2, 3, 7. That's not 2 or 7, so that's our 3. All right. Yeah, that 3 gives us the 6, 8, and 3 here. That 6 does give us the 6 that I predicted. There it is. We get the 5, 8, and 9 here. These can't be the 8, so the 8 goes there. And that finishes the row with a 5, and this finishes the box with something, a 4. Okay, we get the 5 and the 8 here. We get the 9 and the 5 there. These cannot be 5. That's our 5. That's our 3. Okay. And then this row, I need 2, 3, and 9. That can't be 3. That can't be 9. Here, 4, 7, 9. This can't be 4 or 9. So that's our 7. This is the 7 in here. I mean, we're basically done it wherever we look. 4, 9 there. 2, 4, 9. This is a 6. That's 2 and 6. That's 7 and 2 and 7. 2, 3, 9 here. That places the 2. All right. This is 2 or 3. Can't be the 2. That should finish everything. That's 3. That's 2. That's 9. That's 3. That's 9. That's 4. We get the 9, 4, and 2. We get the 9 and the 4, and we're done. All right. a bit of a longer puzzle because I took some time explaining things, but I hope that was helpful. I am expecting some new viewers coming in from TikTok because I have stopped posting to TikTok. So if you are new, say hi. I'd love to hear that. I'd love to hear any feedback. Do remember there is also the video in the description if you want a more detailed account of the basic stuff to look for. And yeah, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.